We will have a very interesting presentation made by Alexey A.Peshkun from Research Center for Earth Operative Monitoring. You know, Canopus-V, by technical capabilities, was designed as a monitoring spacecraft, but its accuracy allows using it for mapping. Also, it did not have a stereo imaging application, but this research center did an interesting research. Mr. Peshkun will share the results of that research with you.
Thank you for the introduction. I welcome all the participants of the conference. I will tell you about our small experiment of building Canopus-V stereopairs. And I will also tell you what we acquired as a result of processing of those stereopairs. Many words have been mentioned today about Canopus-V. Here on this slide you can see the specs of the image block of the Canopus-V. We're not going into further detail about this. And now about the experiment itself. As input data we used two images, two strips acquired from different paths. One of them had clouds in it, but it didn't affect the experiment. We used the central parts of these fragments. For processing we used photo mode, and we used type points for that. This slide shows the process scheme. In fact, everything is quite standard. External orientation, building stereopairs, then digital elevation model, digital terrain model, and ortho rectification. On this slide, you can see microframes from panchromatic channel. As a result of external orientation, we tied all the points from microframes. In overlaps, we measured the ground control point, checkpoints, and the same was done for multispectral frames. We also measured the type points, both GCPs and control points and checkpoints, and then we didn't use it to build the TTM, but we used them later to build the colored orthophoto. Here you can see the schematic of microframes of the two paths. Here you can see some overlap of the two paths, and in automatic form we build a DTM for that. Here you can see how the DTM was created, and then automatically we have done filtration and correction of DTM. As a result, we acquired this. Then we did the precision or accuracy assessment. For that we used 36 GCPs with the RMS 37.3 meters, and by using this DTM model we built orthophoto by transforming microframes of all the channels with the exception of infrared. Multispectral bands were put together into multispectral image, and then we did pen sharpening, and we acquired the full colored orthophoto with the resolution of 2.5 meters. This slide shows the accuracy estimation of the acquired orthophoto. For that we used again 36 GCPs with the standard deviation of 3.2 meters, maximum deviation 8.3 meters. Throughout the process of our study we found out certain dependency between the precision of orientation of images. Here you can see in the first column the number of GCPs, and the second column shows the number of control points. And then you can see the standards of maximum GCPs, and you can see the diagram with the number of GCPs, and you can see that with the 2, 3 type points, with their increase, the RMS error on does not really change. Here you can see the numbers which had been mentioned in the report. This is RMS and maximum deviations of DTM and orthophoto. These errors look to us, seem to us quite satisfactory, and we decided to continue our study. At the moment, the more thorough and detailed study is ongoing. We are doing the image acquisition with different parameters, and then we'll assess the prospects and the capacities of this line of work. This is a topographic map which was made using orthophoto and DTM with the altitude deviation of about 1300 meters. And the conclusions and findings that we can make known is that microframes can be used for stereopairs creation and for DTM creation, and for orientation of the block from 30 microframes to achieve about 1.5 pixels accuracy is enough to have 2, 3 control points. Thank you. That's all I had to tell you. Thank you. Are there any questions for Alexey? No questions. Thank you very much.